Your smartphone connects you, informs you, and entertains you. Let's explore its fascinating origin. We will take you behind the normally closed doors of the smartphone factory. This is the smartphone assembly line, a place of constant activity and incredible innovation. Prepare to discover the meticulous steps involved in bringing your phone to life. We will see how microchips, the brains of the device, are carefully handled and integrated. We will look at the delicate camera lenses that capture your memories. Finally, we will observe the rigorous final quality testing that ensures every device functions perfectly. Before a single smartphone can be assembled, a remarkable journey unfolds, a global ballet of sourcing and coordination. The components originate from all corners of the globe, each part a testament to specialized expertise. Consider the processor, designed in Silicon Valley. The vibrant display might be manufactured in South Korea. The intricate camera module might come from Japan. Creating these miniature marvels requires a deep understanding of optics, engineering, and materials science. Coordinating the movement of these components is a logistical feat of extraordinary complexity. This is where just-in-time logistics ensures the smooth and efficient flow of materials. Specialized software tracks the movement of goods, ensuring timely arrivals. The just-in-time approach, while highly efficient, is not without its challenges. Disruptions to the supply chain can create bottlenecks and delays. Despite these challenges, the smartphone industry has demonstrated remarkable resilience. As components converge at the assembly plant, a new phase begins. Meticulous tracking and documentation. This is where traceability ensures every part can be traced back to its origin. Each component is scanned and logged into a centralized tracking system. This level of traceability serves several crucial purposes. It's essential for quality control and addressing any issues with precision. Traceability is also crucial for environmental responsibility and ethical sourcing. Imagine a space so pristine, so meticulously controlled that even the air itself is filtered to remove the tiniest of particles. This is the clean room environment where the delicate components of your smartphone are prepped for assembly. Workers don gowns, hairnets, gloves, and specialized footwear. The air is constantly circulated and filtered through HEPA filters. Special precautions are taken to ground equipment and personnel. Maintaining this level of cleanliness is a continuous effort. Regular cleaning and disinfection procedures ensure that surfaces remain spotless. Within the clean room, a sophisticated dance of data begins, a ballet of barcodes, RFID tags, and digital records. This intricate system ensures that every smartphone can be traced back to its origin. Barcodes are read with lightning speed, instantly identifying each part. Some manufacturers rely on RFID tags for even greater precision. The traceability system acts as a safety net, preventing mismatched or faulty components. This system provides valuable insights for inventory management and production planning. Before components can take their place in the grand symphony of smartphone assembly, they undergo rigorous inspection and testing. This meticulous attention to detail is crucial in maintaining reliability and performance. Trained technicians examine each part for visible defects. For more complex components, visual inspection alone is not enough. These parts undergo automated tests to assess functionality and performance. Microchips are subjected to varying temperatures and voltages. Only after passing these inspections are components cleared for the assembly line. Our journey now takes us to the production of the device's most vital organ, the PCB or printed circuit board. This thin plate acts as the central nervous system of the smartphone. A complex network of copper pathways connects a multitude of tiny components. The processor is connected to the memory chips. The Wi-Fi and Bluetooth chips enable wireless communication. The process of populating the PCB is a remarkable feat of miniaturization and precision. The density of components on a modern smartphone motherboard is astonishing. The process used to assemble components onto the PCB is known as surface mount technology, or SMT. SMT places components directly onto the surface of the PCB. The SMT process begins with the application of solder paste onto the PCB. The PCB moves to the pick and place machine, the heart of the SMT line. This machine uses vacuum nozzles to pick up tiny components and place them onto the PCB. The precision of these machines is crucial, ensuring that even the smallest components are placed with pinpoint accuracy. Section 3. The reflow oven. Fusing connections with heat. With components precisely placed on their beds of solder paste, the PCB enters the next stage of the SMT process, the reflow oven. This carefully controlled oven is where the magic of soldering takes place, transforming the sticky paste into strong, electrically conductive connections that will hold the components securely in place. The reflow oven is essentially a long tunnel divided into multiple zones, each with a specific temperature profile. As the PCB travels through the oven on a conveyor belt, it's gradually heated to a precise temperature. Melting the solder paste and fusing the component leads to the PCB pads. The temperature profile is critical, too low, and the solder won't melt properly, leading to weak connections. Too high, and the heat could damage sensitive components. The reflow process is carefully monitored to ensure consistency and quality. Sensors inside the oven track the temperature at various points, and the conveyor belt speed is adjusted to ensure that the PCB spends the right amount of time in each zone. The atmosphere inside the oven is also controlled, often using nitrogen to prevent oxidation of the solder and components during heating. As the PCB exits the reflow oven, the molten solder solidifies, creating permanent electrical connections between the components and the board. The PCB, now populated with a multitude of tiny parts, is beginning to resemble the heart of a smartphone, ready for the next stages of assembly. Section 4. Inspection and quality control, ensuring flawless connections. The SMT process, while highly automated, is not foolproof. Tiny errors in component placement, solder paste application, or reflow profiling can lead to defects that could compromise the functionality of the entire phone. That's why rigorous inspection and quality control are essential at every stage of PCB assembly, ensuring that only flawless boards move on to the next stage of production. The inspection process begins immediately after the reflow oven. Automated optical inspection (AOI) systems equipped with high-resolution cameras and sophisticated image processing software scan the PCB surface for any soldering defects. These systems can detect a wide range of flaws, including missing components, misaligned parts, solder bridges, and insufficient solder. For even more detailed analysis, some manufacturers employ X-ray inspection systems. X-rays can penetrate the PCB and reveal hidden solder joints, allowing inspectors to identify internal defects that might not be visible to the naked eye. This is particularly important for components with hidden solder connections, such as ball grid array (BGA) packages, where hundreds of tiny solder balls connect the chip to the PCB. Once any defects are identified, they are either repaired manually or the entire PCB is scrapped, depending on the severity of the issue. The goal is to ensure that only perfectly assembled and soldered PCBs make it to the next stage of smartphone production, where they will be integrated with other components to create the final device. Section 1. The display, a window to a digital world. The journey of smartphone assembly now leads us to the integration of the display, a critical component that serves as our window into the digital realm. Long gone are the days of small monochrome screens. Today's smartphones boast expansive displays, often stretching from edge to edge, capable of rendering vibrant colors, deep blacks, and sharp details. Integrating these delicate and expensive components into the phone's frame is a task that demands the utmost precision and care. The display panel itself is a marvel of modern engineering. Most high-end smartphones now utilize OLED, organic light emitting diode, or AMOLED, active matrix organic light emitting diode technology. These displays offer several advantages over traditional LCDs, liquid crystal displays, including wider viewing angles, faster response times, and deeper blacks, resulting in a more immersive and enjoyable viewing experience. The display panel is incredibly thin, often measuring just a few millimeters in thickness, and surprisingly flexible. It's also extremely fragile, susceptible to scratches, cracks, and electrostatic discharge. Handling these delicate components requires specialized equipment and a dust-free environment to prevent any damage. The display panel is not just a screen. It also houses a variety of sensors and integrated circuits that are essential for the phone's functionality. The touchscreen sensor, for example, sits beneath the display's glass surface, detecting the position and movement of your fingers. Other sensors might include an ambient light sensor, which adjusts the screen brightness automatically, and a proximity sensor, which turns the screen off when you hold the phone to your ear during a call. Section 2. Precision robotics, aligning delicate connections, integrating the display panel into the phone's frame is a multi-step process that begins with the precise alignment of the display with the phone's body. This is where the dexterity and repeatability of robotic arms truly shine. These robotic arms, equipped with specialized end effectors and vision systems, can manipulate the delicate display panel with micrometer precision, ensuring that it sits perfectly within the frame's recess. The display panel is connected to the phone's motherboard via a set of flexible printed circuits known as flex cables. These thin, ribbon-like cables carry electrical signals and data between the display and the rest of the phone's circuitry. The connectors on these flex cables are incredibly small and delicate, requiring a steady hand and a keen eye to align and connect properly. Robotic arms, guided by sophisticated vision systems, carefully align the display panel's connectors with those on the motherboard. Once aligned, the robotic arm gently presses the connectors together, ensuring a secure connection. The entire process is monitored in real time by cameras and sensors, ensuring that the connectors are properly seated and that no damage occurs during the process. In addition to the display and touchscreen connectors, the robotic arm also connects other essential components such as the earpiece speaker, front-facing camera, and ambient light sensor, all of which are often located on a separate assembly that is integrated along with the display panel. Section 3. Human touch, ensuring flawless integration. While robotic arms excel at precision tasks, the human touch remains essential in smartphone assembly. After the robotic arm has completed its work, skilled technicians step in to ensure that the display integration is flawless. They carefully inspect the alignment of the display within the frame, checking for any gaps, misalignments, or protrusions. Even the slightest imperfection can compromise the phone's aesthetics and functionality. Technicians also verify that the display connectors are properly seated and secured. They might use specialized tools to gently probe the connectors, ensuring that they are making good contact. Once they are satisfied with the connection, they apply a small amount of adhesive to secure the flex cables in place, preventing them from coming loose during shipping or normal use. The human eye is remarkably adept at detecting subtle flaws that might escape even the most sophisticated automated inspection systems. Technicians are trained to look for imperfections in the display's appearance, such as dead pixels, uneven backlighting, or color distortions. They might run a series of tests displaying specific patterns and colors on the screen to ensure that the display is functioning correctly. This final human inspection is a testament to the importance of craftsmanship in even the most high-tech manufacturing processes. Section 1. Powering up. The role of the battery. With the display and frame successfully integrated, our journey into the heart of smartphone assembly now takes us to a critical component, the battery. This power source, often taken for granted, is what breathes life into the intricate network of circuits and components that make up a smartphone. Without it, the phone would be nothing more than an inert collection of metal, glass, and silicone. The batteries used in modern smartphones are marvels of energy storage technology. Most smartphones today use lithium-ion batteries, which offer a high energy density, meaning they can store a lot of power in a small and lightweight package. This is crucial for smartphones where portability and battery life are paramount considerations. These batteries are not without their challenges, however. Lithium-ion batteries contain flammable electrolytes, and if damaged or mishandled, they can overheat, catch fire, or even explode. That's why the installation of the battery is a task that demands the utmost care and precision, both to ensure the safety of the workers and to protect the integrity of the phone itself. The battery is typically housed in a dedicated compartment within the phone's frame, often secured with adhesive and/or a removable cover that allows for battery replacement. The battery itself has a set of delicate contacts that align with corresponding contacts on the phone's motherboard, providing the electrical connection that allows the battery to power the device. Section 2. Automated precision, battery insertion and securing. Installing the battery into the phone's frame is a task that is increasingly being handled by automated systems. These systems, often utilizing robotic arms with specialized end effectors, can pick and place the battery with micrometer precision, ensuring that it sits perfectly within its compartment and that its contacts align perfectly with those on the motherboard. The use of automation in battery installation offers several advantages. First and foremost, it enhances worker safety. By removing human operators from direct contact with the battery during the installation process, the risk of accidental damage or mishandling is significantly reduced. Furthermore, automation improves the consistency and reliability of the installation process. Robotic arms, unlike human hands, do not suffer from fatigue or variability, ensuring that every battery is installed with the same level of precision and care. This reduces the likelihood of loose connections, misalignments, or other issues that could affect the battery's performance or safety. Depending on the specific phone design and manufacturing process, the battery might be secured in place using a variety of methods. Some manufacturers use adhesive strips pre-applied to the battery or the phone's frame to hold the battery securely in place. Others might use clips or latches that snap the battery into its compartment. In some cases, a combination of adhesive and mechanical fasteners might be used for added security. Section 3. Rigorous testing, ensuring battery safety and performance. Once the battery is installed and secured, it undergoes a series of rigorous tests to ensure its safety and performance. These tests, often automated, simulate the battery's operation under a variety of conditions, pushing it to its limits to identify any potential issues. One of the most important tests is a voltage check. The battery's voltage is measured to ensure that it falls within the specified range. A battery with a voltage that is too low might not have enough power to start the phone, while a battery with a voltage that is too high could pose a safety hazard. Another crucial test is a capacity check. This test measures the amount of charge the battery can hold, ensuring that it meets the manufacturer's specifications. A battery with a low capacity will not provide the desired runtime, while a battery with a capacity that is too high could indicate a manufacturing defect. The battery is also subjected to a series of stress tests designed to simulate the battery's operation under extreme conditions. These tests might involve exposing the battery to high temperatures, low temperatures, or rapid charge-discharge cycles. The goal is to identify any potential weaknesses or defects that could affect the battery's safety or longevity. Only after passing this battery of tests is the phone deemed ready for the final stages of assembly. The battery, now a vital and thoroughly vetted part of the device, will soon be powering the smartphone experience for its future owner. Section 1. Sealing the symphony. Encasing the technology. With the major components in place, meticulously connected and rigorously tested, the smartphone begins to resemble the sleek device we recognize. It's now time for the final assembly, where the internal symphony of technology is encased within a protective and aesthetically pleasing shell. This stage is not merely about closing a box, it's about precision fitting, ensuring structural integrity, and for many models, achieving the promised water and dust resistance. The smartphone's casing, often made of aluminum, glass, or high-grade plastics, is more than just a pretty face. It provides crucial protection for the delicate components within, shielding them from impacts, scratches, and everyday wear and tear. The casing is often composed of multiple parts, meticulously designed to fit together seamlessly, creating a unibody feel that exudes quality and craftsmanship. The process typically involves securing the back cover of the phone to the frame that houses the display, motherboard, and battery. This might involve snapping the parts together using precision-engineered clips, securing them with tiny screws, or adhering them with specialized glues that offer both strength and the ability to be disassembled for repairs. For smartphones that boast water and dust resistance, this stage takes on additional significance. Tiny gaskets, often made of rubber or silicone, are meticulously placed around ports and buttons, creating a seal that prevents the ingress of liquids and particles. Some manufacturers go a step further, applying a thin bead of waterproof adhesive around the edges of the display and back cover, creating a hermetic seal that gives the phone its coveted IP rating, signifying its level of protection against the elements. Section 2. A symphony of tests, ensuring peak performance. Before being deemed ready for packaging and shipping, the nearly complete smartphone faces a final gauntlet of tests, a meticulous evaluation designed to ensure that every aspect of its functionality meets the highest standards. These tests go beyond simply checking if the phone turns on. They evaluate every aspect of its performance, simulating real-world usage scenarios to uncover any potential issues. One of the first tests is a thorough functional test. This involves powering on the phone and running a series of automated checks that evaluate the functionality of its core components. The touchscreen responsiveness is tested, ensuring that it accurately registers taps, swipes, and gestures. The proximity sensor is checked to ensure that the screen turns off when the phone is held to the ear and back on again when moved away. The phone's audio capabilities are also put through their paces. The earpiece and loudspeaker are tested for clarity and volume, ensuring that calls can be heard clearly and that media playback is loud and distortion-free. The microphones are checked for sensitivity and noise cancellation, ensuring that voice calls are crisp and clear. The cameras, a key selling point for many smartphones, undergo their own set of rigorous tests. The image quality is evaluated for sharpness, color accuracy, and dynamic range, ensuring that photos and videos captured with the phone meet the high expectations of today's consumers. The camera's autofocus system is put through its paces, ensuring that it can quickly and accurately lock focus on subjects near and far. Section 3. Ready for the world packaging and shipping. This smartphone, having passed its final test with flying colors, is now ready for its journey from the factory floor to the eager hands of consumers. This final stage, often overlooked, is a crucial part of the manufacturing process, ensuring that the phone is protected during shipping and presented to the customer in a way that reflects the brand's image and the premium nature of the product. The packaging process begins with careful cleaning the phone, removing any fingerprints or smudges that might have accumulated during assembly and testing. A protective film, often with the brand's logo or other graphics, is applied to the screen, safeguarding it from scratches during shipping. The phone is then placed in its box, a seemingly simple act that is often carefully choreographed to create a specific unboxing experience for the customer. The box itself is designed not only to protect the phone, but also to showcase its design and features. Along with the phone, the box contains the essential accessories such as a charger, USB cable, and a quick start guide. These accessories are often carefully arranged within the box, adding to the premium feel of the unboxing experience. The box is then sealed, often with a tamper-evident sticker, and labeled with the phone's IMEI number, serial number, and other relevant information. The labeled boxes are then placed into larger shipping cartons, carefully stacked and secured to prevent damage during transit. These cartons, containing hundreds of smartphones, are loaded onto trucks or shipping containers, ready to embark on their journey to distribution centers and retail stores around the world. The smartphone, once a collection of raw materials and components, is now a finished product, poised to connect people, share stories, and empower its users. Section 1. The Gauntlet of Quality. No room for error. This smartphone, now fully assembled and encased in its protective shell, might appear ready for the outside world. However, before it earns its place in your pocket or purse, it must prove its mettle. This is where quality control and testing take center stage. A rigorous evaluation process that leaves no room for error. Every function, every component, every aspect of the phone's performance is scrutinized with an almost fanatical attention to detail. This isn't just about catching a few faulty devices. It's about maintaining the integrity of the brand, ensuring customer satisfaction, and upholding the reputation for quality that is paramount in today's competitive smartphone market. A single high-profile recall due to widespread defects can damage a brand's image and erode consumer trust, potentially taking years to rebuild. The quality control process begins long before the final assembly stage, with rigorous testing and inspection of individual components and sub-assemblies. However, it's in this final phase that the smartphone is evaluated as a complete and integrated system, ensuring that all the individual parts work together harmoniously to deliver the seamless user experience that consumers expect. The testing process is often highly automated, automated, utilizing specialized testing rigs and software that can evaluate hundreds of phones simultaneously. These automated systems offer speed and consistency, ensuring that every phone is subjected to the same rigorous tests, regardless of which factory worker or testing station it happens to pass through. Imagine a battery of tests so comprehensive that they simulate virtually every aspect of real-world smartphone usage, from the mundane to the extreme. That's the reality of smartphone quality control, where devices are poked, prodded, dropped, dunked, and subjected to a barrage of simulated user inputs, all in the name of ensuring that they can withstand the rigors of daily life. One of the most basic yet crucial tests is the touchscreen responsiveness test. Using a robotic finger or a grid of pressure sensors, the screen is subjected to a series of taps, swipes, and multi-touch gestures, ensuring that it accurately registers each input and responds with the expected speed and accuracy. The phone's audio capabilities are also put through their paces. The earpiece and loudspeaker are blasted with a variety of test tones and audio samples, evaluating their frequency response, clarity, and maximum volume. The microphones are tested for sensitivity and noise cancellation, ensuring that voice calls are crystal clear, even in noisy environments. To evaluate the phone's durability, some manufacturers perform drop tests, where the phone is dropped from a predetermined height onto a hard surface, such as concrete or tile. These tests help to identify weaknesses in the phone's design and materials, ensuring that it can survive the occasional accidental drop without suffering catastrophic damage. For smartphones that boast water and dust resistance, the IP rating is put to the test. Phones are submerged in water tanks to specified depths for specific durations, ensuring that they remain watertight and functional even after accidental exposure to the elements. Dust chambers filled with fine particles are used to test the phone's resistance to dust and other small particles that might clog ports or interfere with its operation. Section 3. The human element, craftsmanship in the age of automation. While automation plays a crucial role in smartphone quality control, the human element remains essential. Despite the sophistication of automated testing systems, there are certain aspects of quality that can only be evaluated by the discerning eye and skilled hand of a trained technician. After completing the automated testing gauntlet, a significant percentage of smartphones undergo a final round of inspection by human operators. These technicians, often stationed at brightly lit workstations, carefully examine each phone for any cosmetic defects, such as scratches, dents, or inconsistencies in the fit and finish of the casing. They might also perform a series of manual tests, such as checking the buttons for tactile feedback, ensuring that the ports are free of debris, and verifying that the SIM and memory card trays insert and eject smoothly. These might seem like minor details, but they contribute to the overall perception of quality and can make the difference between a satisfied customer and one who feels shortchanged. Furthermore, human technicians play a crucial role in identifying and diagnosing more complex issues that might be missed by automated systems. For example, a subtle color shift in the display, a slight buzzing sound from the speaker, or an intermittent touchscreen unresponsiveness might not trigger a failure flag during automated testing, but would be immediately apparent to a trained human inspector. This final human touch, a blend of technical expertise and subjective judgment, adds an extra layer of assurance to the quality control process, ensuring that only the very best smartphones earn the right to bear the brand's logo and find their way into the hands of discerning consumers. Section 1. A triumph of technology and collaboration. As we reach the end of our journey through the intricate world of smartphone assembly, it's difficult not to feel a sense of awe at the sheer complexity and sophistication of this modern marvel. The smartphone, once a futuristic concept confined to the realms of science fiction, is now an indispensable part of our daily lives, a testament to human ingenuity and our relentless pursuit of technological advancement. The journey from raw materials to a finished smartphone is a testament to the power of globalization and collaboration. Components sourced from every corner of the globe converge at state-of-the-art factories, where they are meticulously assembled with a blend of automated precision and human craftsmanship. This intricate dance of technology and human skill is a testament to what we can achieve when we work together, transcending geographical boundaries and cultural differences in pursuit of a common goal. The level of precision and control required at every stage of the assembly process is staggering. Tiny components, some barely visible to the naked eye, are placed with micrometer accuracy, soldered with carefully controlled heat, and assembled into increasingly complex sub-assemblies. Every step, from the application of solder paste to the final tightening of a screw, is governed by strict quality control measures, ensuring that only the very best devices make it off the production line. This meticulous attention to detail, often invisible to the end user, is what sets the smartphone apart from so many other consumer electronics. It's a testament to the dedication and skill of the thousands of engineers, technicians, and factory workers who contribute to its creation, each playing a vital role in bringing this pocket-sized marvel to life. Section 2. The smartphone, a catalyst for innovation and connection. The impact of the smartphone extends far beyond its sleek design and impressive technical specifications. It has become an integral part of our social fabric, a tool that connects us to each other and to a world of information and entertainment that was once unimaginable. The smartphone has revolutionized the way we communicate. Instant messaging, video calls, and social media platforms have broken down geographical barriers, allowing us to stay connected with friends, family, and colleagues around the world in ways that were once impossible. It has democratized information, giving us access to a wealth of knowledge and perspectives at our fingertips. The smartphone has also become a powerful tool for creativity and self-expression. We use it to capture and share our lives through photos and videos, to express our thoughts and feelings through social media, and to explore our artistic sides through music, writing, and design apps. It has empowered us to become content creators, not just consumers, blurring the lines between professional and amateur and giving rise to a new generation of digital storytellers. The smartphone's impact on the global economy has been equally profound. it has created entirely new industries, from app development and mobile gaming to ride-sharing services and on-demand delivery platforms. It has transformed existing industries such as retail, media, and finance, forcing them to adapt to a world where consumers are constantly connected and expect instant gratification. Section 3. The future in your hand, a glimpse beyond the horizon. As we marvel at the capabilities of today's smartphones, it's tempting to wonder what the future holds for this ubiquitous device. The pace of innovation in the mobile technology sector shows no signs of slowing down, with each new generation of smartphones boasting faster processors, sharper displays, and more sophisticated cameras. The smartphone of the future will likely be more than just a communication and entertainment device. It will be an even more integral part of our lives, seamlessly integrating with other technologies and devices to create a truly connected and personalized experience. Imagine a world where your smartphone acts as your digital key, unlocking your car, your home, and your office. Imagine a world where it monitors your health in real time, alerting you to potential issues and even providing personalized health recommendations. Imagine a world where it augments your reality, overlaying digital information onto the physical world through advanced augmented reality technologies. These may seem like futuristic fantasies, but the building blocks for these technologies are already being developed. Artificial intelligence, 5G connectivity, and advancements in sensor technology are paving the way for a future where the smartphone becomes an even more powerful and indispensable tool, enhancing our lives in ways we can only begin to imagine. The next time you pick up your smartphone, take a moment to appreciate the incredible journey it has taken to reach your hand. Consider the intricate web of technologies, the global collaboration, and the human ingenuity that have gone into creating this marvel of modern engineering. The future is literally in your hand, and it's exciting to think about where this pocket-sized revolution will take us next.
What I wish I knew about YouTube. Before I started, don't forget to hit that like button, drop a comment, and smash that subscribe. Got more cool stuff coming your way. Stay tuned and see you in the next video.